We are live.
Thank you. All right, so thanks for everyone staying, and we're gonna start with our first topic of the course. And this topic is mostly talking about understanding cause and effect. So won't be so much of demoing like the fun stuff that we saw Jason did, but like what we said, we'll be dive into this soon in those labs and then in homeworks that we're gonna work very interactively with Jupyter notebooks. Okay. So topic one is cause and effect, and it's one chapter, one section of the book itself. Okay, so we're gonna talk about relationship between variables or between data points and things like that. And we're gonna start with a link. Okay, so the Guardian is a newspaper in the UK has an article a few years back saying that 3 coffees a day link to a range of health benefits. Okay, so notice the way that they're using the word a link. Okay, there are many different ways to think about what a link really means, and in this course we really want to differentiate two types of links that people are trying to say. Okay, one is the two, so 3 coffees a day, the first item, and a range of health benefits, they are related to each other. Okay, they're associated with each other. Okay, so that's one type of link, association. Okay, but then there's another type of link, what we call causation. Okay, which is I would say, like, based on the title of this news article, 3 coffees a day linked to a range of health benefits is definitely, I think, to me, trying to elude that, well, 3 coffees a day can help you to obtain a range of health benefits. Okay, so depending on the reader, I would say that some people will read the link or a link here as just these two are related, associated with each other. But some of people might read it more like, okay, the first thing is causing the second thing to happen. Okay, so different interpretations, of course. And for this course, early on, like right now, we're trying to differentiate these two types, and we really want to highlight that relationships are multiple types, and then also how to determine whether it's one type or another really affects how we are doing the analysis, or I should say, depending on how the analysis is being done, one type of the relationship that we're talking about can be obtained based on the analysis, but not the other. Okay, so remember, there's association and there is a causation, and we want to try to differentiate those two. Okay, so another, as you know, a lot of the news articles are really about food and the nutrition. Okay, so a stronger link. Okay, chocolate is good for your heart, study finds. Okay, and this, I would say, we won't have time to go into the detail of the study itself, but if you look at this sentence, the title, I think it's hinting more as a causation. Okay, so like it's good for your heart, meaning that if you eat chocolate, well, your heart will become better in whatever sense they're defining. So we do want to highlight this as another example of showing different ways that people are trying to hint their study. And well, the thing is, if you really go into the study, you will always find this kind of discrepancy between the actual scientific study, the findings there, and then the study, how it's done there. Link, how does that affect, or how does that relate to the actual news articles? And a lot of times you will see that a lot of exaggeration is happening in news articles, whereas in the original scientific report, maybe causation is not really being influenced, while as the news article was saying that way. Okay, so for us as a data scientist, we want to get it clear early on. And there are a few definitions we need to get started knowing first. Okay, so observation. Okay, this is one term that you're going to hear pretty often throughout. Okay, we refer observations as individuals. Okay, you can think of them as study subjects or participants, or sometimes a unit, maybe not necessarily as a person, maybe sometimes as a whole household, or sometimes like a whole class, if it's a class level analysis is being done. Okay, in that particular news article, we didn't get the chance to read it, but just so you know, the European adults are the study subjects that they are looking at for the chocolate study, that chocolate is good for your health. Okay, so another important terminology here is treatment. Okay, and treatment in this case is a chocolate assumption. Okay, so if you're really doing a study here, okay, what we care about is, well, you can imagine that, well, in order to do a study like that and try to come up with a conclusion like chocolate is good for your health, then when you have two groups, And then one we'll call it as a treatment group, which will be the group that will have the treatment. In this case, was have higher or a lot more chocolate assumption than the other group, which is what we call the observation group, for example, that they won't be having the treatment. Okay, so whenever we're talking about this relationship between two outcomes, we really need to make sure that we have one treatment group and one non-treatment group. Okay, and the outcome, of course, in our particular study that we're reading just now, is about whether people will have heart disease or not. Okay, so this again, not shown in the title, as you can see, because news article, they were really sometimes exaggerating certain things, but the study itself, the outcome is the heart disease, how many, like the infection over there. All right, so the first question, okay, based on what we're reading chocolate about disease, heart disease, is there any relation between chocolate consumption and heart disease? Okay, so this is a question posting to you actually. And again, we went over the few terminology over here, and then the actual instances in the study. The study was done on European adults, okay, and then they have the treatment of chocolate consumption, so they have two groups, and they're evaluating the outcome of the two groups. Okay, the two groups, the outcome, they're the heart disease status. Okay, so based on what you have seen in that title, do you think there is any relationship between the chocolate consumption and heart disease? Okay, the first one, like what we're talking about, is that we might think that, okay, there probably is association. Okay, we're not saying one is causing the other, because that one is stronger. We have to make more assumptions or making more analysis to make sure that is true. But then based on comparing the two groups, for example, the outcome of the two groups, you might be able to see that, okay, it does show that chocolate assumption, higher chocolate assumption really leads to lower heart disease. So the first question, which is the first definition of our relationship, is association. Okay, so we're not saying one is causing the other, we're just saying that they're related. So for association, we're just hinting any relationship, okay? Or sometimes we'll use the link. Okay, one answer to that, let me just show you the data. Now we get some experts from the news article here. Among those in the top tier of chocolate assumption, 20% developed or died of cardiovascular disease during the study, compared to 17.4% of those who didn't eat chocolate. Okay, so notice here, they are doing a study. Okay, they have two groups. Okay, one group is having chocolate consumption, the other group is not having chocolate consumption. And then the outcome, as we're talking about, is heart disease, right? And they actually evaluated, they numerically evaluated that 12% have developed or died of heart disease during the study from the consumption group. And then the non-consumption group is 17.4%. Okay, so based on this data, let me just ask you, do you think there is a relation between chocolate consumption and heart disease? Okay. Well, discuss with the neighbors. In this case, we're gonna do it quickly using breakout room. So let me, let's see. Jason, I think here you have to pause recording so we don't record. Yep. Pause, not stop. Yeah. Yep. How was the discussion? Did you have a debate, or everybody agreed on one? Okay, some yes, some no's. Okay, we'll see. And I think we're still waiting for one room, so bear with us. Welcome back, everyone. And Jason, I think, oh, okay, you're recording. Okay, sounds good. Yeah, thanks. Okay. Yeah, we're just saying, did you all have a debate in the group, or everybody sort of agreed on there is or there is no association? What do y'all think? You can type in the chat or just speak up, like yes or no, and then we can discuss. Okay, Xia?
We thought it was like a negative correlation. So yes, it is a relationship.
Okay, thanks. And Michael? Oh, Michael, I thought, okay. Oh, there are multiple Michaels. Let me see. I thought, yeah, I saw Michael friend unmuted, so I thought Michael wanted to say something. Was that right?
Oh, no, accidentally.
Never mind. But what about the other Michael? I know I caught on you, so if you want to share anything, feel free.
Yeah, we definitely think that there is a relationship between the two, but not necessarily a causal relationship.
And I guess the reason why you think there's a relationship is because you would think that 12 and 17.5, they're like large enough a difference over there. Is that right?
Right, yeah.
Sounds good. And I think, yeah, and thank you for those who type in the chats about your thoughts and your discussion. So yeah, so many of you, and I think many people actually looking at the difference of the two values will think that there is a link, and the link over here is mostly about association, because we don't really know the causation direction, whether it's the consumption of chocolate leading to heart disease or vice versa, right? Even though maybe intuitively we think, okay, it's about consumption causing lower heart disease rate, but who knows? So the data itself doesn't tell us, and the study itself doesn't tell us. So the next question, now we know that it has a, we think there is association there. Then the next question is, does chocolate consumption lead to a reduction in heart disease? Okay, so this, I think, like I was saying, well, the data, like the study itself, unless we are given more information, it's really hard to tell given what we know so far, okay? But regardless, this lead to term is referring to causality or causation, okay? This question is often much harder to answer, okay? And let me show you one quote from it. The study doesn't prove a cause and effect relationship between chocolate and reduced risk of heart disease and stroke, okay? And well, this is really just a, I guess, like a conclusion, but throughout the course, especially early on right now, we're gonna talk about in what scenario or in how the study was conducted and how that can affect whether we are able to draw a conclusion of association, and in what scenario that we're able to draw a conclusion of causation, okay? But at this point, make sure that you know they're different, okay? And causality is usually a harder question to answer.
Yeah, so one lens that we can view this course is that we're going to give you the tools to answer that question precisely with some meaning behind that.
Yeah, thank you. All right, okay, so for association, let's dive into a little bit more. And we're gonna use the example from early 1850s in London, okay? And this is an illustration from a book in 1852. And maybe some of you have seen this or maybe not, but this is a court for King Clara, okay? So it was a disease back then that people didn't quite understand, and they're causing a lot of trouble back then. And in particular, back then, London has neighborhoods which are better off, the neighborhoods are worse off, and this is happening a lot in the worse off areas, okay? So the scenarios, maybe some of you know, some of you don't. The issue is there are some bad smells, okay, given off by waste and rotting matter, okay? And then people get a lot of bad symptoms over there. Okay, it's like vomiting, diarrhea, things like, and people die in the end, and many of them in the end as well. Okay, and it came and go. Like it's usually like in a year, it started off in somewhere not in London or not in Europe, like Asia, but then slowly advancing through Asia to Europe, and then eventually in London can get really bad in the end. Okay, so people at the beginning, even medicine people like Florence Nightingale and Edwin Chadwick, who is the commissioner of the General Board of Health, they thought, okay, it's just it's the main source of the disease is really just the bad smells that people are observing, okay? And people were suggesting that, oh, just go to cleaner air and then trying to stay clean as you can. And they really think it's the smell. However, there's this person called John Snow, okay, who made a great discovery, and we're gonna walk through how he made his discovery from association to causation in the end, that he was eventually able to figure out what was causing the cholera in the end, okay? So what's interesting about his approach is he took a data science approach, as we are calling it right now, okay? So in particular, he had a map, as you can see, that's the map of a particular area, Soho area of London back then. And in particular, he was, so you will see that it's kind of little stacked up items, okay? And he was, so each of this is representing a death, Okay, so he's really doing a mapped version. Okay, he was trying to find the location of the death, and then he is tallying it up and trying to show a general feature of how the I would say like the distribution of the deaths scattered around in the Soho area. Okay, so you can see that, well, obviously here is a lot. Okay, whereas in some other areas there's none, right? But then many other areas also have a much fewer number of deaths. Okay, so we're going to pause here for a moment. Okay, and I already highlight here that there is a lot of death in this particular area. Okay, and I want you to take a look at the map a little bit closer, a closer look, and think about what might be the issue. I know it's a really open-ended question at this point, but try to pay attention to different symbols and logos that it's being marked on this map. And then if you find anything interesting or fishy, or like maybe can help you decide certain things, let us know. I'm gonna try to, oh, I think I have to stay on the presenter mode so you can see it. So feel free to speak up. I will just pause for like a minute or so. And then, because I couldn't see everybody's face at this point because it's full screen on my end. But if you have some thoughts, feel free to unmute and speak up. And after a minute or so, we're going to move on to understanding it together. Go ahead.
So everywhere that I see like a lot of deaths, I also see like a short little like line, which I'm assuming if it's like cholera, maybe it's like a sewer line or something.
Oh, yeah, good point. Well, now we in the hindsight, right, we know what is causing it. So yeah, so sewage indeed is an important factor. Later on, people find out. So I don't know the answer whether like that line that you're referring to will be sewage or not. But on a related, so I'm trying to lead you guys to a way to think about it is that a particular symbol that is being labeled here on this map is the water pump. Okay, so there's one here.
So this is the time before plumbing. And so if you wanted to get water, you would walk down to the pump and then you would just pump it and it would be attached to wells.
Yeah,
And so
exactly.
some of those pumps are scattered throughout. There's one kind of in the middle, hint, hint, but there is one in the upper left-hand corner as well. And there's one right, yeah.
Yeah, there's one here, there's another one here, and I think this one is probably another one,
Yep,
but it's
yep.
yeah, okay. Yeah, but it was right. Sorry, I couldn't see the name who was answering the question, but yes, it is related to water, but then back then it's really showing off in terms of the location of the pump. Okay, so indeed, the pump on the Broad Street, which is the street over here, has a lot of death around it. Okay, and that's where Jon Snow starts to get a little bit suspicious of, oh, I don't really think it's the heir. Especially, there's so many row houses like scattered around in London, and then he was noticing in particular that while some houses, adjacent houses, some of them everybody was fine, but then the next house everybody was not fine. Okay, so since they're breathing the same air, he was really suspicious that it's not really about the air or anything. But then once he started putting this onto a map and then doing the tally here, he started to see a pattern. And then we want to highlight to you that is the pump. Okay, that later on was figured out as the issue. Okay, so we're going to get into it in more detail soon, but if you're curious, if you do a Google search, Google map, you will see that in that area around the Broadway area, there's a Jon Snow pub, and it's, well, high rated, I guess. If you ever visit London, maybe pay a visit to that as well. And also there's a pump, okay, over here. It's not used anymore, right? Okay, so this is actually a memory for him because in the end, he was suggesting it's not really the air, it's probably about the pump, and then the water is probably contaminated. So how about you turn it off? Okay, put the handle off. Okay, so in the end, the city actually did that, and then the cases of cholera reduced a lot. Okay, so this is really like a memory for memorial for Jon Snow, and then he was using data in that sense that trying to figure out that there is a association, right, between the pump and then the number of death cases. Okay, and the issue here, as you can see, is that, well, from this data that you're able to see, we really just can see that there are a lot more death counts around this particular pump. Okay, but we don't know if it's indeed the pump causing the death, right? We know that they're related to each other. So at this point, what John Snow can say was really just there's association. Okay, but he was right that once he cut off the association by putting off the handle of the pump, the cases reduced a lot. Okay, so but that alone, again, cannot say that it's the pump leading to the issue of the colors, the death cases. Okay, so he really needs to do something else, and we're gonna carry on next Tuesday when we come back of how he actually used causation, or I should say use a particular study to figure out the causation, and then he succeeded, and then that was a really important story and history in the public health space.
Great. So I think we're at time, so we'll let you go. So welcome. We're excited to have you here. Excited to be back. Just a reminder that you have the option of attending lab tomorrow in person. And so this is, the lab will be held in Sanders Physics, room 309. So remote is fine too, whatever you're most comfortable with. So I'll be in lab in 309, and we actually have the adjacent lab as well, known as the Asprey lab. So I think the stated capacity of Sanders 309, Sanders Physics, I think we can fit 10 people in, but then we can fit another 10 or so in the adjacent labs. And I'll be kind of circling between the two labs. So it doesn't matter which one you go into, and then Monica will be leading the online lab as well. So we'll see you either in person or virtually tomorrow. Thanks, everyone.
Thank you, everyone. Take care. See you tomorrow. Let's start today's lecture. And we will, as you see that last time, we were able to go over most of lecture one, topic one, cause and effects. But in particular, I think we stopped at roughly where John Snow was trying to use, remember the tally of the death counts on the map, and then trying to figure out whether, like, what was the real reason behind those diarrhea. And then he realized that it's not so much about the air, right? It's about the water, right? But then at that point, it's really just about association, like what we talked about, because well, we see a difference, but we cannot say whether one thing causes the other, okay? But back then, John Snow actually figured out how to do the causality statement as well. So that's what we're gonna continue today. So I'm gonna share my screen. I think everybody should be able to see this, okay? All right, so the causation, okay, that's the sort of like the last topic of this, last subtopic of this cause and effect topic is, let's try to figure out how John Snow did his final study of the causation, okay? So here's a map. This is another map, okay? This is the map of London water supply, okay? And let me just show you, there are two companies, two water companies. One is Southwark and Vauxhall, which is going to call it SNV, okay? So you see that it's on the northern part of London. And then the other company, water company, is called Lambeth, okay? And it's in the southern part, okay? What's special, as you can see here, is that the water, like the sewage beneath the city. So in fact, the SMV, they receive water from downstream of sewage, and then Lambeth, they receive water from the upstream of sewage, okay? So I mentioned this mostly because I think now we all know it's about the water. So like where the water is received above or below the sewage will be important. But back then, people didn't really know, okay? But what's important and interesting on this map, as you can see, is that there is one area, which is what we label both, okay? That is the area where the households in this area actually could receive, like some households receive from like SMV, the other one receives from Lambeth, okay? So I want to highlight here, because I'm gonna ask you actually the question that if you are given this map, okay? And then remember, for us, to establish a causality or causation relationship, we need to compare, okay? Remember last lecture we talked about, well, if you are doing a experiment like this, in order to establish this kind of relationship, you will need to have a treatment group and a control group, okay? And then you're gonna compare them. If you remember our discussion about the chocolate and heart disease, right? And we have those treatment group who has consumed a lot of chocolate, and then the control group who does not. And then we're comparing that two values, 12 and 17.4%, okay? That's the outcome in the heart disease percentages. So my question for you, keep in mind about this, this map before I send you to the breakout room, is that, well, remember that we want to compare, okay, compare the outcome, which I guess in this case will be the diarrhea and the cholera symptoms. On this map, if you are selecting a particular area of households to do the comparison, which one you're going to choose and why? So let me send you to the breakout room. This is probably going to be quick, but take your time. I'll bring you back in a second. Okay. So the question, sorry if some of you didn't hear it clearly. The question is, now we have this London water supply map, okay, and we know, well, or John Snow back then, he knew that it's about the water, okay, and we indicated that there are 2 water companies, okay, and depending on where you live, you might only get water from SMB, or you might only get water from Lambeth, or one particular area, which is the Beauce up here, is some households receive water from one and some others receive water from the other, okay? So the question was, we know that we want to do comparison, and the treatment, of course, in this case, will be what kind of water you're receiving, okay? And then in particular related to the sewage, okay? So the treatment group will be whatever is receiving, I guess, the water that we know from the Broadway pump, okay? And the other one is the control group, which does not receive the treatment. So this is generic, okay? But in our case, in particular, if we were to do a comparison here, especially we know that there's 2 different water companies and then one is above, one is below the sewage. So the particular area that you will want to choose to do this comparison is that Beauce area, okay? Because as we will see soon, that if you choose all of the households to do your study in this area, okay, we know that some of those households going to receive water from SMB, okay? Some others going to receive water from Lambeth. What's important is that we can generally assume that households in this overall area are going to share most of the other characteristics very similar from each other, except that some of them are receiving water from one and the others are receiving water from the other company. Okay, so as you will see that in order to establish causation, what's very important is that we really want to what we call control, okay? Control the observations between the treatment and the control group. Meaning that, so if we actually repeat and then quote from Snow's grand experiment, there's no difference whatever in the houses or the people receiving the supply of the 2 water companies or in any of the physical conditions with which they are surrounded. Okay? So what this is telling us, as we highlight below here, is that the 2 groups are similar except for the treatment. Okay? And that's a key in establishing what we mean by causality or causation. Okay? When you do this kind of experiment, or when you design this kind of experiment, you want to make sure that the 2 groups, the treatment group and the control group, they're only different by the treatment that they're receiving. Okay, treatment group is receiving the treatment while the control group does not receive the treatment. Okay, so in terms of what we do in this particular example, like what we were describing earlier, that households in the Beauce area, they are similar except for the water supply. Okay, so in that way, we're able to eliminate the effects of the other characteristics, like I guess food supply or just the environment in general. They will be similar, but the only difference between those 2 groups at this point will be the water supply. Okay, so actually, I have a table here based on what John Snow had done back then. Okay, so the supply area, we are showing it in the first column. Okay, the column over here, and we are comparing the first water company, SMB. The second is Lambeth, and the third is rest of London. We're just going to show you for comparison. Okay, so the number of houses, well, this is in the Beauce area. Okay, it's 40,000 versus 26,000. Okay, the cholera death counts are 12,098 respectively, but we also, very importantly, when we're doing this kind of comparison, we want to make it on the same scale. Okay, so the last column is giving you deaths per 10,000 houses. Okay, so it's 315 for SMB, 37 for Lambeth, and then 59 for the rest of London. Okay, So based on this, what do you think is the reason, or can you, like, I guess earlier we already talked about that we're able to establish causality if we're doing this kind of experiments, we control for everything else. And then now with this table, with this difference in the number of deaths per 10,000 houses, what do you think? Which one or what is causing, you think, the cholera death in particular? And the note down here we're showing is SMV is below the sewage and Lambeth is above the sewage, as we were talking about earlier. Okay. So I will bring you back to the breakout room. I know this probably will be quick, and just remember the question here is, given this table, what do you think is the cause of the cholera deaths that we're seeing here? Okay. So without further ado, all right, so let's hear from some of you if you're willing to share your thoughts. Okay, so given this table, okay, we compare the deaths per 10,000 houses in the two areas. And remember, we have controlled, okay, we have control for the other characteristics of those households. They're only different by the water source that you're taking. Okay, so anybody wants to share what you think, or the discussion out of your breakout room? What is your conclusion here and why?
Yeah, so we looked at the or remembered it. So even though Lambeth is a smaller number of houses in total,
Yeah.
The number of deaths per 10,000 people is significantly lower than SNV.
Mhm.
And also, if you look at the rest of London, that's also larger, and it's a larger number of houses, but it makes sense that the lower, if you're farther from the sewage, you're going to have less deaths.
Yeah, sounds good. Yeah, so I think Shell was just pointing out a very important aspect that we really need to focus on the ratios, right? Because we put them on the same scale for comparison, because as Shell pointed out, the number of houses were quite different between the two water supply areas and then the rest of London. But then if we put it on the same scale, looking at deaths per 10,000 houses, then clearly Lambeth is having the lowest and almost like 10%, right, of the one under SMV. So again, because we already identified that we're able to establish causality over here. So this biggest difference between the two, almost 10% of the death rate is indicating that, well, is probably the water supply of Lambeth, which now we know is about the sewage, below the sewage of SMV, that is causing the cholera deaths. Okay, and I should just point out before we move on, because I remember last week when we ended the first lecture, some of you stayed over and asked about, well, if we're just comparing the numbers and then we see how do we know exactly whether the difference is big enough or not? Okay, so that's a good question, and I think many of you who, if you have experience with statistics in the past, you will probably know that, oh, you actually need to do certain tests before you're able to say anything for certain. So I would just say that, yes, down the road in this course, you will see that we will do this kind of more detailed analytical solutions back then. But right now, we're really just focusing on the comparison between the association and causation. Okay, and then we're just trying to focus on how to differentiate these two, as well as what are the key aspects that we're looking at. Okay, so we will get to those tests, and you will see that how we can do that once we have learned the nuts and bolts of doing Python programming. Okay, sounds good. So lastly, for this topic, I just want to highlight that the role of data science and data scientists. Now you see that we need to know, okay, where and what to look. Okay, just like that example, we need to make sure that we know it's the both area, okay, that we should be focusing. Because the other areas, if you only focus on, let's just say, the let's just SMV only or Lambeth only, we're not too sure about the other characteristics. Okay, we're not able to control for them, so those are not the good solutions to choose. Whereas the both area, we're able to control the treatment and the group. Okay, and we will need to learn all of this because they're going to be very useful for analyzing the collected data. But I would say maybe more importantly, as a data scientist, as you get involved in the study design, like all of the knowledge and skills should also go into designing the study and the experiments. Okay, so I should just say that, like John Snow back then, this the study was not designed, if you think in that way. Like, it was natural. So it was a natural experiment. And he was really smart to come up with that you can just really just focus on the both area. But in fact, in many of the, I guess, modern studies that we're doing now or will be doing in the future, you really want to design your experiments and study in a sound way that you're able to make those analysis in the future. Okay. And I will just wrap up here saying that the key to establishing causality again is that we need to make sure that the treatment groups and the treatment and control groups, they are similar except for the treatment. Then if you observe any difference in the outcome, you can attribute that difference to the treatment itself. Okay? Otherwise, there might be certain things that might not be able to help you to make your conclusion here. Okay? So with that in mind, get to the last topic here. Since we're talking about well, we really need to make sure that we have control for the characteristics between the treatment group and the control group. So I'm going to show you one more thing, that sometimes if you don't control them, you might get what we call confounding variables or confounding information that are going to distract you or like make your conclusion not sound. All right. So the trouble if the treatment and control groups actually have systematic differences other than the treatment. Okay, say for example, for that water supplied example, what if the SMV area, SMV only area, the households all receive not only water from SMV, but also let's just say they get their meat from a particular vulture, let's just say, okay? Whereas the Lambeth group, they not only receive water from Lambeth only, but also they receive their supply of meat from another butcher, okay? So this is actually what we call systematic differences, okay? Meaning that there are other characteristics that are systematically different between the two groups. So in this case, it might be difficult to identify the causality itself, okay? However, such differences are often present in observational studies, okay? So observational studies, we talked about it before, that is, when you do not do any kind of control, you just have observation. So, or I should say, if you have a study, but like you're not able to control the treatment group and the control group. So such differences are often present in those cases. And that's why, well, first of all, we know that observational studies that in those cases, we won't be able to establish causality, like the best you can do is the association, okay? But also important as we see now, that those confounding factors going to affect observational studies and the experiments, which is the causality studies as well. Okay, so we really need to make sure that we don't really have systematic differences other than the treatment for the experiments. So let me show you one example, and you might have all kinds of reasons of why you think these two are so related to each other. So both of them, okay, let's see. So this is, we're putting on the same scale, so don't worry about like y-axis exactly what they represent. But you can see that we're putting on the same scale, and then this is looking at ice cream sold and murders, okay, between May and July, okay? So if you're just looking at this, you can say that, or you might want to say that, okay, they're highly correlated, if you know the word, or like they have a really strong association, okay, of these two. Okay? But if you really try to come up with a reason, or like say whether murders is causing more ice cream sold or vice versa, or like why exactly these two are related, it might be quite confusing because it's not something intuitive to think about, like what was the reason. But then another variable, just as an example, another variable in this case actually could probably be the temperature, okay? So the temperature, which could be a confounding variable here, is related to ice cream sold as well as related to murders. But then if you take that out from the picture, like what we're doing right now, you're really only seeing the relationship with ice cream sold and the murders. But then those two might not necessarily related to each other, okay? Both of them are related to the temperature, okay, but not necessarily with each other. So this is what we mean by confounding. And there is a very interesting website. I actually will encourage you to take a look, and we will now take a look of whatever they're showing right now on their website. Is called Spurious Correlations, okay? It's actually a book, and it's funny that people try to come up with all kinds of funny results or correlations out there. So, and they posted on this website, pretty interesting. And you will see that they have what they call like a correlation coefficient, which we're gonna learn later in this course as well. But the idea is that, well, if you have two variables like this, you are able to compute the correlation coefficient between the two, and the higher, the closer it is to one, the stronger the positive correlation. Okay, so these tables or these graphs are just showing you certain what they call spurious correlations. The first one is U.S. spending on science, space, and technology correlates with suicide by hanging, strangulation, and suffocation. And the correlation is as high as 99.79%. Like I said, closer to one, the higher the correlation. So I don't know the particular reason behind, but this will be some data that if you just collect them and then just plot them, whatever the way that you like, and it might start to look a little bit suspicious or not really important relationship that's showing now, and that this could be important for you to start to think about whether there are confounding variables behind it. Okay, I will just show another example. Like I said, feel free to check out the website later. Say the number of people who drowned by falling into a pool correlates with films Nicolas Cage appeared in. I guess that's even random. Like it's for whatever reason is going together between like starting from 1999 to 2009. Okay, but well, I don't know the reason behind, but just so you know, a lot of times we do collect data and we want to show their pattern. But sometimes if you don't make sure that there's no confounding variable out there, that the results that you're seeing might not be what you're really seeing. Okay, so those are important lessons, and I hope you will later get a chance to take a look of the website and then think hard about those results. Okay, so lastly, just to highlight one more time, how can we make sure that we can get rid of those systematic differences? Okay, so the thing you could do is what we call randomize. Okay, so imagine now we're in the space of designing the experiments, okay, or designing the study here. If you are able to assign individuals to treatment and control groups, remember we have two groups. One is receiving the treatment, we call it treatment group. The other one is control, does not receive the treatment. If we're able to assign individuals to these two groups at random, meaning that like we have 50, let's just say we have 50 observations or individuals, we randomly take one out of the 50 and put it in one of the two groups. And then we keep doing that unless each is having 25 individuals, each group has 25 individuals, but then the entire process is random. Then the two groups are likely to be similar apart from the treatment. Okay, so this reasoning is that if we are able to randomly assign individuals into two groups before we provide the treatment to the treatment group, then we're having a higher chance that the two groups are going to be very similar to each other on any other aspects, except for the fact that one group later going to receive the treatment and the other group later is going to not receive the treatment. Okay, so this is the key that you will see of establishing causality. Okay, and we are able to, in this case, account mathematically for variability in the assignment. And we call this kind of experiment as randomized controlled experiment. Okay, randomized, the term is talking about we're doing assignment at random. Okay, control, again, control, the words here is mostly to talk about we're able to control between the treatment group and the control group of the other characteristics other than the treatment itself. Okay, so later in the course, you will see that how we can use Python programming to help us to do randomization of assigning individuals or subjects into different groups at random. And then we're able to do the comparison like the one that we were seeing on the table of Snow's-Grant experiments earlier. Okay. So definitely be careful. Okay, sometimes like random, the word, hopefully you will get more used to it. In this space, in data science and statistics, in this space, we are talking about at random. Okay, it doesn't mean haphazard or anything, but we're trying to provide the reasoning of how to do things at random, meaning that you are able to do it without any other factors. And then Python programming in particular will be super helpful for you to get to that point. All right, I hope all of this overall makes sense. And any quick questions before we go to topic 2, tables? Okay, all right, yeah, okay. If not, let's